November 9th, 1929. A Turkish museum curator named Halil Edhem opens a dusty portfolio in the Topkapi Palace Library and freezes. He's cataloging old Ottoman manuscripts, routine work he's done 1,000 times before, but what he's looking at shouldn't exist. The document is a map drawn on gazelle skin parchment, dated 1513 and signed by an Ottoman admiral named Piri Reis. The map shows the Atlantic Ocean, the coast of South America, and the coast of Africa with reasonable accuracy for the period. But at the bottom of the map, drawn with surprising detail, is a coastline that extends south from South America, a coastline with mountains and bays and rivers, a coastline that looks unmistakably like Antarctica. The problem is simple and insurmountable. Antarctica wasn't officially discovered until 1820, over 300 years after this map was drawn, and the features shown on the Piri Reis map, the subglacial coastline beneath miles of ice, wasn't mapped by modern science until 1949, using sophisticated echo-sounding equipment. Yet here it sits, drawn 5 centuries earlier, impossible and undeniable. If you're drawn to historical mysteries that challenge accepted narratives, if you question how ancient peoples accomplish things that seem beyond their capabilities, then make sure to subscribe and turn on notifications, because this investigation goes places you won't expect. Share this with anyone who appreciates evidence that doesn't fit neatly into conventional explanations. And if this mystery captivates you the way it has captivated researchers for decades, leave a like to help others discover what may be one of history's most profound enigmas. What we're about to explore exists in archives and libraries around the world, documented by serious scholars, yet it remains one of the most suppressed controversies in academic circles because the implications are simply too disturbing to contemplate. The Piri Reis map became public knowledge in the 1930s, but it took decades before anyone realized its full significance. The map was examined by numerous scholars who noted its historical value as an early Ottoman cartographic work, but the truly shocking aspects went unrecognized for years. It wasn't until 1956 when a Turkish naval officer sent a copy of the map to the United States Navy Hydrographic Office that the real mystery began to unfold. The Navy forwarded the map to specialists who had been involved in mapping Antarctica during recent expeditions. These experts, expecting to politely note some interesting historical curiosities, instead found themselves confronting something inexplicable. The coastline shown at the bottom of the Piri Reis map matched the subglacial topography of Queen Maud Land in Antarctica with disturbing accuracy. Not the ice-covered surface that explorers had documented, but the actual rocky coastline hidden beneath thousands of feet of ice. This coastline had only recently been discovered using seismic sounding and ice-penetrating radar technology. The correspondence wasn't vague or approximate. It was specific and detailed, showing bays and inlets in their correct relative positions. How could a map drawn in 1513 show geographic features that weren't discovered until the 20th century, using technology that didn't exist in the 16th century? The silence from official academic channels was deafening, but among researchers willing to examine the evidence objectively, the Piri Reis map became the starting point for an investigation that would eventually uncover dozens of similar impossible maps. Piri Reis himself provides crucial information about how he created his map, information that only deepens the mystery. In notes written directly on the map's margins, the admiral explains that he compiled his chart using approximately 20 source maps, some dating back to the time of Alexander the Great in the 4th century BC. He specifically mentions using maps captured from Spanish sailors, charts from the Arabic cartographic tradition, and most intriguingly, a map that had belonged to Christopher Columbus himself. Piri Reis claims that Columbus had access to ancient maps showing lands across the Atlantic, which guided his voyage rather than him sailing blindly into unknown waters. This revelation aligns with long-standing rumors that Columbus possessed secret knowledge about lands to the west. Several contemporary accounts mention Columbus consulting with learned men about ancient texts and maps before his voyage. The Spanish court's willingness to fund his expedition might make more sense if he presented evidence of lands across the ocean rather than just a theoretical argument about reaching Asia by sailing west. If Columbus did have ancient maps showing the Americas, and if Piri Reis acquired one of these maps, then the source of the Antarctic coastline becomes even more mysterious because it pushes the timeline back centuries earlier. But Piri Reis goes further. He mentions maps from the time of Alexander the Great, which would date to around 300 BC. Alexander's conquests brought Greek scholars into contact with ancient libraries in Egypt and Mesopotamia, repositories of knowledge accumulated over thousands of years. If maps from this era showed Antarctica, it means someone was exploring and charting the southern continent over 2,000 years ago, during a period when no civilization should have possessed the maritime capability for such voyages. The implications stagger the imagination, yet Piri Reis states this matter-of-factly, as if compiling information from ancient sources was a normal part of cartographic work. The Ottoman Empire in the early 16th century was at its height, controlling vast territories and inheriting the intellectual legacy of the Byzantine Empire, which in turn had preserved much Greek and Roman knowledge. The Topkapi Palace Library contained manuscripts and maps collected from across the known world. If ancient maps showing Antarctica existed anywhere, the Ottoman archives would be a logical place to find them. Piri Reis, as a respected admiral and cartographer, would have had access to these archives. His map isn't presented as a revelation or discovery, but as a compilation, synthesizing various sources into a coherent chart. He didn't realize he was creating something impossible. He was simply doing his job. The Piri Reis map stood alone as a bizarre anomaly for decades, until researchers began systematically examining other ancient and medieval maps for similar impossibilities. In 1960, Dr. Charles Hapgood, a professor of history at Keene State College, was conducting exactly such a survey when he encountered the Orontes Phineas world map from 1531. This map, housed in the Library of Congress, shows all known continents with reasonable accuracy for the period. But in the position of Antarctica, the map displays an entire continent with remarkable detail, including mountain ranges, rivers, and coastal features. The continent is labeled Terra Australis and is drawn with a level of accuracy that shouldn't have been possible in 1531. What makes the Orontes Phineas map particularly striking is its shape. The Antarctic continent is drawn with roughly accurate proportions and even shows features like the Ross Ice Shelf and the Antarctic Peninsula in approximately their correct positions. The interior details include mountain ranges that correspond to actual subglacial mountain ranges in Antarctica. These mountain ranges were only discovered by modern expeditions using ice-penetrating radar in the 1950s and 60s. Yet here they appear on a map drawn 400 years earlier, positioned with geographic accuracy that seems impossible without aerial or satellite observation. Dr. Hapgood compared the Orontes Phineas map with modern maps of the Antarctic subglacial topography and found correlation after correlation. Coastlines matched within reasonable tolerances. Mountain ranges appeared in correct relative positions, even the overall shape of the continent, distorted by the map's projection but recognizable, aligned with modern knowledge. Hapgood's analysis suggested that the Orontes Phineas map was based on source maps created when Antarctica was at least partially ice-free, when the coastline and interior features could be observed and charted directly. This would require dating the original surveys to a period before the Antarctic ice sheet reached its current extent, potentially thousands or even millions of years ago. The academic response to Hapgood's findings was swift and dismissive. Critics argued that the correlation between ancient maps and Antarctic geography was coincidental, that map makers were simply drawing speculative land masses in unknown regions and happened to guess correctly. Others suggested that Hapgood was engaging in confirmation bias, seeing patterns where none existed. But Hapgood anticipated these objections and addressed them methodically in his research. The level of detail and accuracy in multiple maps, the consistency of features across different cartographic traditions, and the specific correlation with subglacial geography all argued against coincidence. The controversy forced Hapgood's work to the margins of academic discourse, but it couldn't erase the evidence he had compiled. In 1737, French cartographer Philippe Buache published a map of Antarctica that poses perhaps the most direct challenge to conventional history. The Buache map shows Antarctica divided into two major landmasses separated by a waterway. This division corresponds precisely to what modern geologists now know about Antarctica, that it's actually two continents, West Antarctica and East Antarctica, separated by a deep channel that would be a strait if not for the ice sheet covering it. This geographic reality wasn't discovered by modern science until the International Geophysical Year of 1957, when seismic surveys revealed the subglacial topography. Yet Buache's map from 1737 shows this division clearly. How did Buache know this? In his notes accompanying the map, he explains that he based his representation of Antarctica on earlier maps and on deductions about how southern lands must be arranged. But this explanation doesn't hold up under scrutiny. The division of Antarctica into two continents isn't something you could deduce from ocean currents, climate patterns, or any other observable phenomena available in the 18th century. It's a specific geophysical fact that requires direct observation of the land beneath the ice. Buache must have been working from source maps that showed Antarctica before complete glaciation, or from maps based on surveys that somehow penetrated the ice sheet to determine the underlying topography. The Buache map also shows the continent with surprising accuracy in other respects. The overall shape, while not perfect, captures the general outline of Antarctica far better than random guessing would produce. Coastal features appear in approximately correct positions. The map even indicates mountainous regions in the interior that correspond to actual subglacial mountain ranges. Every detail on the Buache map represents information that shouldn't have been available in 1737, information that wouldn't be confirmed until the 20th century, yet there it sits in archives, documented and authenticated, drawn 2 centuries before the knowledge it displays was supposedly acquired. Critics have attempted to explain away the Buache map by arguing that the division of Antarctica was a theoretical conjecture based on symmetry, or other aesthetic principles of cartography. But this argument fails when we examine Buache's other work. He was a rigorous cartographer who based his maps on empirical sources and was cautious about speculation. His map of Antarctica is presented not as a hypothesis, but as a representation based on sources, the same way he presented his maps of other continents. The straightforward conclusion is uncomfortable, but unavoidable. Buache had access to source material showing Antarctic geography as it exists beneath the ice. Gerardus Mercator, one of history's most famous cartographers, created a world map in 1569 that revolutionized navigation with its innovative projection. But Mercator's Arctic and Antarctic regions present puzzles that have largely been ignored in standard histories of cartography. His map of the Arctic shows a large landmass at the North Pole divided by rivers into 4 sections, surrounded by a circular ocean. No such landmass exists at the North Pole today. It's ice-covered ocean. However, some researchers have suggested that Mercator's Arctic map might depict conditions from a much earlier period when the polar configuration was different. Even more intriguing is Mercator's treatment of Antarctica. His world map shows a large southern continent with considerable detail, despite the fact that Antarctica wouldn't be circumnavigated until the 1820s. Mercator openly acknowledged that his polar regions were based on ancient sources rather than contemporary exploration. He specifically mentioned deriving his Arctic depiction from a book called Inventio Fortunatae, written by an unknown Flemish author in the 14th century, which described northern lands visited during a voyage. This admission that he was working from ancient sources for unexplored regions suggests that his Antarctic representation might also derive from ancient knowledge rather than contemporary exploration or speculation. What makes Mercator's map significant isn't just the detail in Antarctica, but the cartographic tradition it represents. Mercator was synthesizing knowledge from multiple earlier mapmakers and sources, continuing a tradition of cartography that stretched back through medieval Arab and Greek geography to ancient sources that are now lost. The maps we have from 16th and 17th century European cartographers might be preserving fragments of much earlier geographic knowledge. knowledge compiled by civilizations whose maritime and surveying capabilities exceeded what we've attributed to them. Mercator himself apparently believed he was preserving ancient wisdom rather than creating new knowledge. In 1558, Niccolò Zeno published a map and narrative claiming to document voyages taken by his ancestors, the Zeno brothers, to the North Atlantic in the 1390s. The Zeno map shows Greenland, Iceland, and other northern lands with surprising accuracy for the 14th century. It also depicts islands and lands in the North Atlantic that don't appear on other contemporary maps, including mysterious places named Friesland and Estotaland. For centuries, historians dismissed the Zeno narrative as a fabrication and the map as a fantasy or forgery. But detailed analysis of the map has revealed something unexpected. It contains accurate information about Greenland's geography that shouldn't have been available in the 14th or 16th centuries. The Zeno map shows the eastern coast of Greenland with inlets and fjords that correspond to actual geographic features. Some of these features weren't surveyed by European explorers until the 19th century. The map also shows part of Greenland's northern coast and suggests knowledge of the island's overall shape that wasn't confirmed until aerial photography in the 20th century. If the Zeno map is a 16th century fabrication, how does it contain accurate geographic information about regions that weren't explored until centuries later? The most logical explanation is that the Zeno brothers, or someone before them, did indeed explore these regions, or that the map is based on even earlier sources showing northern geography. The Zeno map connects to our investigation of Antarctic cartography through what it suggests about the preservation of geographic knowledge. If accurate maps of remote northern regions circulated in medieval Europe derived from earlier explorations that are now forgotten or dismissed, then the same could be true for southern regions. The tradition of map-making might have preserved fragments of ancient geographic knowledge through centuries of copying and compilation, with later cartographers not fully understanding the age or origin of the information they were reproducing. The Zeno map suggests that extraordinary geographic knowledge existed in earlier periods and was sometimes preserved in unlikely ways. In 1339, a cartographer named Angelino Dolcert, sometimes called Dell'Orto, created a portolan chart of the Mediterranean and Atlantic that demonstrates cartographic sophistication difficult to explain with the technology and knowledge supposedly available in the 14th century. Portolan charts used by medieval sailors for navigation show coastlines with remarkable accuracy, often matching modern maps with surprising precision. The Dolcert portolan shows the Mediterranean coasts with accuracy that wouldn't be improved upon until the 18th century. It shows Atlantic islands in their correct positions, and even depicts parts of the African coast with detail that shouldn't have been available decades before Portuguese exploration of the region. What makes portolan charts so mysterious is that they appear suddenly in the late 13th century without clear predecessors. Earlier medieval maps were crude and symbolic, showing theological geography rather than practical coastlines. Then portolan charts emerge, fully developed, extraordinarily accurate, and using sophisticated projection techniques. Where did this cartographic knowledge come from? The charts themselves provide a clue. They show evidence of being copied from earlier sources, with some including anachronistic information about coastlines that had changed or cities that no longer existed. This suggests that portolan charts were preserving ancient maritime knowledge, possibly from Roman or even earlier sources. The connection to Antarctic cartography lies in the implications of portolan accuracy. If medieval European sailors possessed extraordinarily accurate maps of the Mediterranean and Atlantic, maps that showed coastlines with precision not achieved again until modern surveying, then it's not impossible that similarly accurate maps of other regions, including Antarctica, might have existed. The portolan tradition demonstrates that ancient maritime cultures possessed cartographic capabilities far beyond what we typically attribute to them. These capabilities included precise measurement of distance and direction, understanding of projection and scale, and systematic survey techniques. A civilization capable of creating the portolan charts would certainly have been capable of surveying and mapping Antarctica if they had the maritime capability to reach it. One of the most disturbing implications of the Antarctic maps is what they suggest about the state of Antarctic glaciation when the original surveys were conducted. Antarctica today is covered by an ice sheet averaging over 2 kilometers thick. This ice has accumulated over millions of years, with the continent having been substantially glaciated for at least 34 million years, according to standard geological models. Yet maps like the Piri Reis and Orientaeus Phineas maps appear to show Antarctic coastlines and interior features as they would look without ice cover, or at least with significantly reduced ice. This creates a temporal problem that conventional explanations struggle to address. If these maps show Antarctica as it appeared before complete glaciation, they must be based on surveys conducted millions of years ago, long before humans existed. This is obviously impossible within conventional history. The alternative is that Antarctica was ice-free or partially ice-free much more recently than geological models suggest, perhaps within the last 10,000 or 20,000 years. This would require radically revising our understanding of Antarctic glaciation and potentially of global climate history. Either alternative is deeply problematic for conventional science. Some researchers have proposed that Antarctica might have been substantially ice-free as recently as 6,000 years ago, during a period called the Holocene climatic optimum, when global temperatures were slightly warmer than today. Mainstream glaciology rejects this possibility, arguing that the Antarctic ice sheet is far too massive to have melted and reformed in such a short time. But the ice core evidence that supposedly proves long-term Antarctic glaciation has been challenged on methodological grounds, with critics arguing that dating assumptions might be flawed. If Antarctica was partially ice-free within human history, advanced maritime cultures could have explored and mapped it before it refroze. When modern cartographers analyze the projection and perspective used in maps like the Piri Reis and Orientaeus Phineas charts, they discovered something startling. These maps appear to be compiled from source maps that used sophisticated projection techniques, in some cases showing features as if viewed from high altitude or even orbital perspective. The Piri Reis map, for example, uses what appears to be an azimuthal equidistant projection centered on Egypt, a technique that accurately represents distances from the central point, but requires sophisticated mathematical understanding to execute. More puzzling still, some features on these maps appear distorted in ways consistent with viewing the curved Earth from a high vantage point. Mountains appear compressed and foreshortened in ways that match how they would look from an aircraft or satellite. Coastal details show perspective effects that would only be visible from altitude. This raises an impossible question. How could 16th century map makers, or their ancient sources, depict Earth's geography with perspective effects that require aerial observation? No aircraft or balloons existed in any ancient civilization we know of, yet the maps suggest aerial viewpoints. Dr. Charles Hapgood, working with mathematicians and cartographers in the 1960s, analyzed numerous ancient maps and concluded that many showed evidence of being compiled from aerial surveys or from observations made from very high vantage points. The mathematics of the projections, the systematic nature of the distortions, and the overall perspective all pointed to source surveys conducted from altitude. Hapgood speculated that an unknown ancient civilization might have possessed aircraft or high-altitude observational capabilities, or that the maps preserved knowledge from a time period we don't understand. His conclusions were too radical for mainstream acceptance, but his mathematical analysis was rigorous and has never been adequately refuted. Perhaps the most sophisticated aspect of ancient cartography is the evidence that worldwide maps were created using a common coordinate system based on latitude and longitude. Accurate determination of latitude has been possible for millennia using observations of the sun and stars, but longitude remained a challenge until the development of accurate chronometers in the 18th century. Yet several ancient and medieval maps show evidence that the cartographers who created the original source maps possessed accurate knowledge of longitude for locations around the world. The Piri Reis map, when analyzed, shows correct longitudinal relationships between different land masses with accuracies that shouldn't have been possible in 1513. Africa's position relative to South America is correct. Mediterranean locations align properly with Atlantic features. The eastern and western hemispheres show correct phase relationships. This implies that whoever created the original source maps had solved the longitude problem centuries or millennia before Harrison's chronometer. They possessed either extremely accurate portable timekeeping devices or some other method for determining east-west position that we don't understand. Analysis of multiple ancient maps by researchers like Hapgood revealed that many seem to use a common prime meridian passing through or near the Great Pyramid of Giza in Egypt. This suggests that an ancient global mapping project might have been coordinated from Egypt, with surveyors fanning out to map different regions but maintaining consistent reference points and coordinate systems. The organization and technical capability required for such a project staggers the imagination, yet the evidence in the maps themselves points toward exactly such a coordinated global effort at some point in the deep past. One of the strongest arguments for the existence of ancient mapping knowledge is the pattern of decline and loss in cartographic accuracy over time. Roman maps showed the Mediterranean world with considerable accuracy, using projections and distance measurements that were quite sophisticated. But after the fall of Rome, European cartography entered a dark age. Medieval maps abandoned accurate distance and direction in favor of symbolic representation of theological geography. Coastlines became crude and stylized. The TO maps of the medieval period showed the world as a circle divided into 3 continents arranged around a T-shaped pattern of seas, bearing no relationship to actual geography. Yet Portolan charts emerge in the 13th century showing accuracy far exceeding anything from the intervening centuries, suggesting they preserved knowledge from Roman or earlier sources that had been lost to mainstream European culture. Similarly, Arab cartographers of the medieval period possessed geographic knowledge that seemed to come from sources independent of their contemporary exploration. The pattern suggests that accurate ancient maps existed and were sometimes preserved through dark ages and cultural upheavals, surfacing occasionally when someone rediscovered forgotten archives or when copies were made before sources were lost. The Antarctic maps fit this pattern perfectly. They show geographic knowledge that seems impossible for their ostensible creation dates, suggesting they're copies of much earlier sources. The cartographers who drew them probably didn't understand the significance of what they were depicting. They were simply copying older maps, doing their best to preserve information they had inherited. Over time, through repeated copying, errors accumulated and details were lost, but fragments of the original accuracy remained enough to reveal that the source maps contained genuine geographic information about Antarctica acquired through methods we don't understand. In 1957, a peculiar artifact surfaced in Turkey that might provide additional context for the Piri Reis map. A stone tablet was discovered showing what appeared to be a portion of Antarctica with astonishing detail, including what some researchers identified as man-made structures or cities. The artifact, if genuine, would suggest that whoever mapped Antarctica also inhabited it, or at least established settlements there. However, the provenance of the Reis stone is questionable, and many scholars consider it a modern forgery or misidentification of a Roman-era artifact showing some other location. Nevertheless, the Reis stone points to a broader question. If Antarctica was mapped in ancient times, was it also inhabited? A continent cannot be mapped without extensive on-the-ground exploration, which implies prolonged presence and possibly settlement. If an advanced ancient civilization possessed the maritime technology to reach Antarctica and the surveying capability to map it accurately, they likely would have established bases or settlements to support their exploration. Evidence of such settlements would be buried beneath kilometers of ice, effectively impossible to detect with current technology unless we knew exactly where to look. The notion of ancient Antarctic settlement seems fantastic, yet it's the logical implication of accepting the maps as genuine surveys. A coast cannot be accurately charted from a ship alone. Surveyors need to go inland, climb mountains to get vantage points, follow rivers to determine their courses, and establish base camps for extended operations. Ancient Antarctic explorers would have needed substantial infrastructure to support their mapping efforts. Where is this infrastructure now? Buried under ice, lost to time, reduced to Unrecognizable fragments by millennia of glacial movement. We might never find physical evidence of ancient Antarctic settlement, even if it existed, because the ice has erased all traces. If we accept that Antarctica was mapped in ancient times, we're forced to confront questions about the technological capabilities of whoever conducted the mapping. Reaching Antarctica from any inhabited continent requires crossing thousands of kilometers of open ocean, navigating through some of the world's most dangerous waters. The ships capable of making such voyages would need to be large, sturdy, and well provisioned. The navigational knowledge required would need to include understanding of ocean currents, wind patterns, and celestial navigation. The surveying equipment would need to include precision instruments for measuring distances and angles. Ancient civilizations are not typically credited with possessing such capabilities. We know that Polynesian peoples crossed vast expanses of the Pacific in wooden boats, proving that sophisticated maritime technology existed in prehistory. We know that Roman and Phoenician ships were capable of long ocean voyages, though they typically hugged coastlines. But reaching Antarctica would require going far beyond what any ancient civilization is credited with achieving. It would require technology and knowledge that we assume didn't exist until the European age of exploration at the earliest, and really not until the 19th century when specifically ice-strengthened ships were developed. Yet the map suggests that someone possessed these capabilities long before modern times. Either our understanding of ancient technological capabilities is wrong, or some civilization we don't know about achieved maritime and navigational sophistication far beyond what we attribute to ancient peoples. The maps themselves are primary evidence that such capabilities existed, evidence that cannot be easily dismissed because the artifacts exist, are authenticated, and contain information that requires explanation. The technology necessary to create accurate maps of Antarctica existed at some point in the past, whether we can currently explain it or not. Professor Charles Hapgood, whose analysis of ancient maps we've referenced repeatedly, developed a controversial hypothesis to explain how Antarctica could have been mapped before its official discovery. Hapgood proposed that Earth's crust could shift relative to its interior, causing entire continents to move thousands of kilometers over relatively short geological timescales. In this model, Antarctica might have been positioned further north in the recent past, with a climate temperate enough to support exploration and mapping by ancient civilizations. A subsequent crustal shift would have moved Antarctica to its current polar position, where it froze over, but maps created before the shift would have been preserved and copied through subsequent millennia. The crustal displacement hypothesis has been almost universally rejected by geologists, who point out that no mechanism known to physics could cause the entire crust to shift while the interior remained stable. The energy required would be enormous, and evidence of such shifts should appear clearly in the geological record, but doesn't. However, some variants of the idea, involving true polar wander, where Earth's entire body reorients relative to its spin axis, have limited scientific support. True polar wander happens very slowly over millions of years, too slowly to have placed Antarctica in a temperate zone during human history, but it does demonstrate that planet-scale geographic reconfigurations are possible in principle. Regardless of whether Hapgood's specific mechanism is correct, his broader point remains valid. The maps exist and require explanation. If crustal displacement isn't the answer, some other explanation must be found for how Antarctica was mapped with such accuracy so long before its official discovery. Hapgood's contribution was to take the maps seriously as evidence rather than dismissing them as frauds or coincidences, and to demand that any historical model account for their existence. His work opened a field of inquiry that continues to challenge and provoke researchers willing to examine evidence objectively. One of the most puzzling aspects of the ancient Antarctic maps is the relative silence from mainstream academia about their implications. The maps exist in authenticated collections, their age is not seriously disputed, and their content is available for anyone to examine. Yet very few academic papers discuss them, and those that do typically offer dismissive explanations without engaging deeply with the evidence. The maps are treated as curiosities rather than challenges to historical understanding, footnotes rather than central problems demanding explanation. This silence is not entirely surprising given the career risks associated with proposing heterodox theories in academic settings. A scholar who argued seriously that ancient civilizations mapped Antarctica before 1900 would face ridicule, difficulty publishing in prestigious journals, and potential damage to their professional reputation. The safer path is to ignore the maps or to offer conventional explanations, however inadequate, and move on to less controversial topics. This institutional pressure toward conformity means that potentially revolutionary evidence goes unexamined because the implications are too threatening to established historical narratives. But the silence isn't complete. On the margins of academia, in independent research, and in the work of a few courageous scholars willing to risk their reputations, serious investigation of the ancient maps continues. Alternative theories are proposed and debated. New evidence is compiled. Mathematical and geographic analyses are conducted and refined. This work proceeds slowly, hampered by lack of institutional support and active hostility from mainstream gatekeepers, but it proceeds nonetheless. The maps themselves guarantee that the mystery won't disappear because the evidence sits in archives and libraries, available to anyone willing to look and think critically about what it means. If we accept that Antarctica was mapped in ancient times with accuracy requiring direct survey, we're forced to consider that a sophisticated civilization existed in a period much earlier than conventional history acknowledges. This civilization possessed advanced maritime technology, sophisticated surveying and mathematical capabilities, and organizational capacity for large-scale geographic exploration. They explored and mapped not just their local region, but potentially the entire world, creating a global coordinate system and compiling information from multiple regions into comprehensive world maps. What happened to this civilization? If they were advanced enough to explore Antarctica, why don't we have other evidence of their existence? The most common answer among alternative researchers is that this civilization was destroyed in some cataclysm, possibly the end of the last ice age, when sea levels rose dramatically and climate changed rapidly. Such a cataclysm could have destroyed coastal cities where the civilization might have been concentrated, scattered survivors, and broken the chains of knowledge transmission that preserved their technology and learning. Later civilizations would have inherited fragments, including maps, without understanding their source or significance. This scenario, while speculative, at least accounts for the evidence in a coherent way. It explains why maps showing impossible knowledge exist, why they appear to be copies of earlier sources, and why the civilization that created the originals left no other obvious trace. It suggests that human history is far longer and more complex than conventional models allow, with rises and falls of sophisticated cultures stretching back into periods we consider prehistoric. This revised history would require rewriting textbooks and rethinking how we understand human development, which explains the resistance to seriously considering it despite the evidence. Advanced analysis of the ancient maps reveals something even more startling than their accurate depiction of coastlines, the mathematical sophistication of their construction. When researchers plot the locations shown on maps like Piri Reis onto modern latitude-longitude grids and account for the projection methods used, they find that distances between widely separated locations are accurate to within margins that require precise measurement. The Mediterranean coastline on the Piri Reis map, when measured against actual distances, shows errors of less than 1%. Caribbean islands are positioned relative to each other with similar precision. This precision is extraordinary because it implies that whoever's conducted the original surveys had standardized units of measurement, accurate instruments for determining distances, and systematic methods for compiling local surveys into larger maps. They weren't estimating or guessing. They were measuring precisely and recording their measurements in ways that preserved accuracy through whatever copying and compilation processes produced the maps we now possess. Modern surveying didn't achieve comparable accuracy until the 18th century, after the development of precision instruments and mathematical methods for error correction. Some of the maps also show evidence of trigonometric methods for determining positions, using angles and baseline measurements to calculate locations of distant points. This requires understanding sophisticated mathematics, including trigonometry and possibly calculus-like methods for dealing with curved surfaces. The intellectual and technical infrastructure necessary to produce such maps is substantial, implying not just a few skilled individuals, but an entire civilization with educational systems, professional standards for surveyors and cartographers, and institutions for preserving and transmitting technical knowledge across generations. Several of the ancient maps showing Antarctica depict rivers flowing through the interior of the continent. The Orontes Phineas map is particularly detailed in this regard, showing multiple major river systems draining the interior toward the coast. Modern Antarctica has no surface rivers because temperatures are too cold for liquid water, but beneath the ice sheet, subglacial rivers do exist, carved into the bedrock by meltwater from geothermal heat. These subglacial rivers weren't discovered until very recently using ice-penetrating radar and seismic surveys, yet ancient maps show rivers in Antarctica in approximately the correct locations. The presence of rivers on ancient Antarctic maps has two possible explanations. Either the maps show conditions when Antarctica was warm enough for surface rivers, which would require either that Antarctica was positioned differently or that global climate was dramatically warmer, or the maps somehow depict the subglacial hydrology that exists beneath the ice. Neither explanation is comfortable for conventional history. If Antarctica had surface rivers in the recent past, it challenges everything we understand about Antarctic glaciation. If ancient surveyors somehow detected subglacial rivers beneath the ice sheet, it implies sensing technology we can barely imagine. A third possibility, suggested by some researchers, is that the rivers shown on ancient maps represent features that existed millions of years ago during the Eocene period, when Antarctica had a temperate climate and lush vegetation, but this requires that maps were somehow preserved from the Eocene to the present, which is obviously impossible since humans didn't exist 40 million years ago. Unless we're willing to entertain truly radical possibilities about non-human intelligence in Earth's deep past, we're left with the conclusion that Antarctica had surface rivers at some point during human history, which requires revising our understanding of climate history and glaciology. What makes the Antarctic maps collectively convincing is that the same impossible knowledge appears in multiple independent sources from different time periods and cartographic traditions. The Piri Reis map from 1513, the Orontes Phineas map from 1531, the Mercator maps from 1569, the Buache map from 1737 all show Antarctica with detail that shouldn't have been available when they were drawn. The consistency across these maps, despite being created by different cartographers in different countries over more than 2 centuries, strongly argues against coincidence or lucky guessing. If only one map showed Antarctica accurately, we might dismiss it as a fluke. But when multiple maps from different sources show the same impossible knowledge, the probability of coincidence drops to negligible levels. Moreover, the maps aren't identical. They show Antarctica from different perspectives, using different projections, emphasizing different features, yet all are recognizably depicting the same landmass with similar accuracy. This pattern is exactly what we'd expect if multiple cartographers were copying from different ancient source maps showing Antarctica, each preserving somewhat different information, but all deriving ultimately from genuine surveys of the continent. The fact that these maps circulated in Europe during the 15th through 18th centuries also tells us something important. Knowledge of Antarctica, however fragmentary and poorly understood, was present in late medieval and early modern cartographic traditions. Mapmakers had access to sources showing a southern continent, sources they didn't fully understand but faithfully copied. This knowledge was circulating at the highest levels of European scholarship, in the same libraries and intellectual networks that were compiling ancient Greek and Roman texts recovered from Arab libraries and Byzantine archives. Antarctic knowledge was part of a broader rediscovery of ancient learning during the Renaissance. The ancient Antarctic maps, by arguing that the correlations with actual Antarctic geography are either coincidental or the result of wishful thinking by researchers predisposed to find patterns. Geologists point out that Antarctica has been glaciated for millions of years, making it impossible for humans to have mapped it in an ice-free state. Therefore, any apparent correlation between ancient maps and Antarctic geography must be explained in other ways, either as speculative drawing of unknown lands that happen to resemble Antarctica, or as misinterpretation of the maps by modern researchers seeing what they want to see. This dismissal faces a significant problem. The correlations are specific and numerous. When multiple distinct geographic features on ancient maps correspond to actual features of Antarctica, and when these correspondences include interior topography that would only be visible without ice cover, the coincidence explanation becomes statistically implausible. The geographic features aren't vague or general, but specific bays, inlets, mountain ranges, and coastline contours. Explaining all these correspondences as lucky guesses requires belief in remarkably good luck sustained across multiple maps from different cartographic traditions. The geological evidence for long-term Antarctic glaciation is itself not as solid as often claimed. Ice core dating relies on assumptions about deposition rates that might not be constant over time. The presence of fossilized vegetation in Antarctic rock layers proves the continent was once temperate, and dating when this occurred involves models that could potentially be revised. Some geologists have proposed that Antarctic ice coverage might have fluctuated more dramatically than standard models suggest, with periods of partial deglaciation during warm climate phases. If Antarctic glaciation is less stable than assumed, it opens possibilities for human-era mapping that conventional models exclude. Tracing the lineage of maps backward through time reveals a pattern of degradation and loss. Later maps are generally less accurate than earlier ones, not more accurate as we'd expect if cartographers were gradually improving knowledge through new exploration. The Piri-Reis map from 1513 is more accurate in some respects than maps drawn a century later. Portolan charts from the 13th century show Mediterranean coastlines more accurately than many maps from the 15th century. This pattern of decline suggests that early maps were copying from superior sources that later became unavailable or less understood. This pattern of cartographic succession points toward an earlier period when more accurate and comprehensive maps existed, maps that subsequent ages partially preserved through copying but never fully replicated. Each generation of copying introduced errors, lost details, and corrupted features. Without access to the original surveys or understanding of the projection methods used, later cartographers did their best to preserve information but inevitably degraded it. The maps we have are corrupted copies of copies, generations removed from the originals, yet still preserving enough accuracy to reveal that the originals contain genuine geographic knowledge. If we could trace the succession all the way back, following each map to its sources, where would we end up? Piri-Reis tells us some of his sources date to the time of Alexander the Great. Medieval Arab cartographers referenced Greek and Roman sources. The Romans had access to knowledge from Carthaginian and Phoenician maritime cultures, each link in the verse. Chain takes us further back into history, toward an origin point where original surveys were conducted by a culture whose identity remains mysterious. This culture had the technology and knowledge to explore and map the world, including Antarctica, and their work was preserved through millennia of copying, corruption, and partial loss until fragments reached the Renaissance mapmakers whose work we still possess. In 1960, the United States Air Force contracted with Professor Charles Hapgood to examine ancient maps for possible geographic intelligence value. Hapgood's analysis, which identified numerous anomalies, including the Antarctic maps we've discussed, was delivered to the Air Force but never publicly released in full. Portions of his findings were later published in his book, Maps of the Ancient Sea Kings. But the complete military analysis remains classified. Why would the U.S. military classify analysis of ancient maps? What sensitive information could possibly be contained in 16th century cartographic artifacts? One possibility is that Hapgood's analysis revealed information about Antarctic geography that the military considered sensitive in the context of Cold War territorial claims. Antarctica was being explored and claimed by multiple nations in the 1950s and 60s, and any information about the continent's geography, resources, or strategic value would have intelligence implications. If ancient maps showed Antarctic features that hadn't yet been discovered by modern exploration, revealing this publicly might have prompted other nations to investigate those features, potentially finding strategic resources or locations before the United States could. Another possibility, more speculative but more interesting, is that Hapgood's analysis revealed evidence of ancient civilization so compelling that military and intelligence officials decided it should be suppressed to prevent social disruption. The existence of an advanced, ancient civilization capable of global mapping would challenge religious and historical narratives that many consider foundational to social stability. It would raise questions about what else might be hidden in ancient archives or buried under ice, potentially triggering destabilizing races to uncover ancient knowledge or technology. Whether or not such concerns were justified, they might have motivated classification of Hapgood's work. In 2016, satellite images of Antarctica revealed what appeared to be pyramid-shaped structures protruding from the ice in several locations. These formations sparked immediate controversy, with some researchers claiming they were artificial structures built by an ancient civilization, while mainstream scientists insisted they were natural mountain peaks shaped by wind and ice erosion. The debate has never been conclusively resolved because the structures are in remote locations, difficult to access, and no expedition has yet examined them up close with the explicit purpose of determining whether they're natural or artificial. The pyramid controversy connects to the ancient maps because if Antarctica did harbor ancient settlements, we might expect to find architectural remains. Pyramids, being massive stone structures, would be among the most likely ancient constructions to survive beneath ice or protrude through it as glaciers shifted. The pyramid-like forms visible in satellite imagery might be natural formations, but their symmetric appearance and the fact that multiple such formations appear in different Antarctic locations has fueled speculation that they deserve closer investigation. Official response to the pyramid controversy has followed the familiar pattern of dismissal without thorough investigation. Scientists who publicly suggested the structures might warrant closer examination faced ridicule and professional consequences. Expeditions to examine the structures have not been funded or have been denied permits. This suppression of inquiry, whether motivated by skepticism about the likelihood of artificial structures or by other concerns, ensures that the question remains unresolved. If the structures are natural, close examination would settle the matter definitively. The refusal to conduct such examination suggests either that authorities are confident they're natural and see no need to waste resources confirming the obvious, or that they're not confident and prefer not to risk discovering something inconvenient. Throughout this investigation, we've encountered a consistent pattern. Evidence exists that challenges conventional historical narratives, evidence that's documented, authenticated, and available for examination. This evidence suggests that human history is more complex than standard models allow, with possible advanced civilizations in earlier periods, or with ancient peoples possessing capabilities we don't credit them with. When this evidence is brought forward, it's typically dismissed by mainstream academia without thorough engagement, using explanations like coincidence, fraud, or misinterpretation that don't adequately account for the specificity and consistency of the anomalies. The ancient Antarctic maps are part of this larger pattern. They sit alongside other historical mysteries, like the precision of ancient megalithic structures, the sophistication of ancient astronomical knowledge, the legends of global floods and lost colonizations found in cultures worldwide, and numerous other anomalies that don't fit comfortable into conventional historical frameworks. Each piece of evidence taken alone might be explained away. But the cumulative weight of multiple independent lines of evidence, all pointing toward greater sophistication and capability in ancient times than we typically acknowledge, becomes harder to dismiss. This pattern suggests that our understanding of human history might be fundamentally incomplete. We may be missing entire chapters, civilizations that rose and fell without leaving obvious traces, or whose traces we've misinterpreted or overlooked. The ancient maps are windows into this hidden history, fragments of knowledge preserved through millennia, waiting for those willing to examine them without prejudice to reveal what they genuinely show about human capabilities and history. We end where we began, with an impossible map showing a continent that shouldn't be there, drawn with accuracy that shouldn't be possible, based on sources that shouldn't exist. The Piri Reis map and its companions remain, stubbornly refusing to fit into conventional explanations, challenging us to either expand our understanding of history or to become increasingly creative in explaining away evidence we find uncomfortable. The choice is not between believing in ancient aliens or accepting mainstream history without question. The choice is between taking evidence seriously and following where it leads versus protecting comfortable narratives by dismissing inconvenient facts. Antarctica was mapped before it was discovered, and that's the problem, a problem that won't disappear through dismissal or ridicule. The maps exist in archives and libraries where anyone can examine them. The correlations with Antarctic geography can be checked against modern satellite imagery and topographic data. The questions about who made the original surveys, how they achieved such accuracy, and what happened to the civilization that possessed such capabilities all remain unanswered. These questions deserve serious investigation by researchers willing to follow evidence rather than predetermined conclusions. Perhaps future Antarctic expeditions will discover ruins beneath the ice, confirming that ancient peoples did indeed inhabit the continent when climate conditions permitted. Perhaps new dating methods will reveal that Antarctic glaciation is less stable than we thought, with periods of deglaciation during human history. Perhaps archives in Istanbul or Rome or Beijing will yield additional ancient maps that clarify the sources Piri Reis and others used. Or perhaps the mystery will deepen, with new discoveries raising more questions than they answer. Whatever comes, the ancient maps have already accomplished something profound. They've proven that our understanding of human history is incomplete and that our ancestors possessed capabilities we've systematically underestimated. The maps are evidence of something, and that something was remarkable. Until we understand what it was, the investigation continues, driven by evidence that refuses to be explained away, and by researchers who refuse to accept that impossible answers to uncomfortable questions should remain forever unasked. The Topkapi Palace Library in Istanbul holds over 13,000 manuscripts, many never fully cataloged or studied by modern scholars. When Halil Adhem discovered the Piri Reis map in 1929, he was conducting routine cataloging work, not searching for geographic anomalies. This raises a compelling question. How many other extraordinary maps and documents remain hidden in archives around the world, waiting for someone to recognize their significance? The answer is likely substantial, given that most major libraries and museums have collections far too large to be thoroughly examined by the limited number of specialists available. Piri Reis himself was not just a cartographer, but a successful naval commander who participated in numerous military campaigns before devoting his later years to geographic scholarship. His nephew was the Grand Admiral of the Ottoman fleet, giving Piri access to the highest levels of Ottoman society and to archives that contained materials seized during the conquest of Constantinople in 1453. When the Ottomans took the Byzantine capital, they captured libraries containing manuscripts that had been preserved since Roman times. Some of these manuscripts were copies of even earlier Greek, Egyptian, and Mesopotamian documents. The Piri Reis map might have been based partly on Byzantine sources that themselves drew on ancient Mediterranean maritime knowledge stretching back thousands of years. The map's construction reveals something fascinating about Ottoman cartographic practices in the early 16th century. Piri Reis didn't simply copy one source map. He synthesized information from approximately 20 different sources, as he notes in his annotations. This means he had to reconcile different projections, different scales, and different levels of accuracy, combining them into a single coherent map. This process requires sophisticated understanding of cartographic principles and the ability to recognize and correct distortions when transferring information from one projection to another. The fact that Piri Reis successfully integrated sources of varying age and accuracy into a map that still shows remarkable geographic precision demonstrates both his personal skill and the sophisticated cartographic tradition he worked within. What happened to Piri Reis after he created his famous map tells us something about the politics of knowledge in the Ottoman Empire. He continued his naval career and later wrote a comprehensive book on navigation and naval warfare called Kitabibari, the Book of the Sea. This work contained detailed descriptions of Mediterranean ports, sailing routes, and maritime conditions, illustrated with numerous maps and charts. Piri Reis rose to the rank of admiral and commanded fleets in the Indian Ocean, where he fought Portuguese forces competing for control of trade routes. His career ended in 1554 when he was executed on the orders of the Ottoman Sultan, allegedly for abandoning a siege, though some historians suggest his execution was politically motivated. With his death, direct knowledge of his sources and methods died too, leaving us only the map and his brief annotations to puzzle over. Piri Reis's claim that he used a map belonging to Christopher Columbus deserves closer examination because it suggests Columbus had access to geographic knowledge that official histories don't acknowledge. According to Piri Reis, a Spanish sailor captured during a naval battle told him about a map Columbus had used, which showed lands across the Atlantic. If true, this means Columbus wasn't sailing blindly into unknown waters based on a mistaken calculation of Earth's circumference, as standard histories claim. He was following ancient maps that showed the American continents. Several pieces of circumstantial evidence support this possibility. Columbus spent years trying to convince European monarchs to fund his expedition, suggesting he had more to offer than just a theory. Contemporary accounts mention that Columbus consulted with learned men about ancient texts and that he studied geography extensively before his voyage. His son Ferdinand wrote that Columbus had access to ancient writings describing lands to the west. Paolo Toscanelli, the Florentine astronomer who corresponded with Columbus, allegedly had access to ancient maps showing lands across the Atlantic. All of this suggests that Columbus possessed knowledge beyond what the official story acknowledges. If Columbus did have ancient maps showing the Americas, where did they come from? One possibility is the Phoenicians, the ancient maritime culture that dominated Mediterranean trade from roughly 1200 to 500 BC. Phoenician ships were capable of ocean voyages, and some researchers have argued that Phoenician artifacts found in the Americas indicate pre-Columbian contact. If Phoenicians reached the Americas and mapped those coastlines, their maps might have been preserved in Mediterranean libraries and archives, eventually reaching Columbus through various intermediaries. Another possibility is that Roman-era sailors, pushing the limits of their maritime technology, reached American shores and created maps that were preserved even after the fall of Rome. The most intriguing possibility, however, is that Columbus's maps came from the same ancient sources that produced the Antarctic maps. If an unknown ancient civilization conducted global exploration and created world maps showing all continents, portions of these maps might have survived and been copied through medieval times. Different fragments might have preserved different portions of the original global survey. Columbus might have had access to fragments showing the Americas, while Piri Reis had access to both American and Antarctic portions, allowing him to create his more comprehensive map. This would explain why both Columbus's voyage and the Piri Reis map display impossible knowledge, while also explaining why the knowledge was fragmentary and incomplete. Modern cartographers have conducted detailed technical analysis of the Piri Reis map to determine its accuracy and to understand the methods used in its construction. Professor Charles Hapgood worked with students at Keene State College to plot locations from the Piri Reis map onto modern grids, accounting for the projection method used. The results were startling. The South American coastline was accurate to within half a degree of longitude, a precision that shouldn't have been possible given that accurate longitude determination wasn't achieved until the 18th century with the invention of the marine chronometer. The Mediterranean coastline on the Piri Reis map shows similar precision. When comparing distances between various ports and landmarks on the map to their actual geographic positions, the errors are typically less than 1%. This level of accuracy matches or exceeds many European maps from the 18th century, yet the Piri Reis map was drawn in 1513 using sources that were supposedly much older. How could ancient or medieval cartographers achieve such precision without modern surveying instruments, without accurate clocks for longitude determination, and without the mathematical methods that enable modern map-making? The answer might lie in the sheer scale of the effort. If the original surveys that produced the source maps Peary Race used were conducted over many generations by a civilization devoted to geographic knowledge, they could have achieved high accuracy through patient accumulation of measurements. Ancient surveyors could determine latitude quite accurately using observations of the sun and stars. For longitude, they might have used methods we don't fully understand, perhaps involving lunar observations, perhaps using extremely accurate water clocks or other timekeeping devices, or perhaps using some technique we haven't considered. Given enough time, resources, and systematic effort, even primitive technology can produce remarkably accurate results. The Antarctic portion of the Peary-Reese map has been particularly controversial in accuracy assessments. Skeptics argue that the correlation between the map and actual Antarctic geography is weak and requires generous interpretation to see any correspondence. Proponents counter that the correspondence is clear when you account for the projection method and understand that the map shows the subglacial coastline rather than the ice-covered surface. The debate often becomes technical, involving arguments about which projection was used, how to account for distortions, and which Antarctic features should correspond to which features on the map. Both sides can cite measurements supporting their position, making resolution difficult. While the Peary Race map has received the most attention, the Oronteus Phineas map from 1531 arguably presents an even stronger case for ancient Antarctic knowledge. The map shows the entire Antarctic continent with internal features, including mountain ranges, river systems, and coastal details. The overall shape matches Antarctica's actual outline with remarkable fidelity, especially considering that Antarctica wouldn't be circumnavigated until the 1820s and its complete coastline wouldn't be accurately mapped until the 20th century. Oronteus Phineus, whose Latin name translates to Orontes Phineae, was a distinguished French mathematician and cartographer who held the chair of mathematics at the Collège Royal in Paris. He was not a fabulist or sensationalist, but a respected scholar working in the mainstream of Renaissance cartography. His world map of 1531 was based on earlier sources, as was standard practice, and he made no claims about the southern continent being based on recent exploration. He simply labeled it Terra Australis, the southern land, and drew it with considerable detail, apparently copying from sources he had access to in Parisian libraries and archives. The most striking feature of the Oronteus Phineas map is how it shows Antarctica before the ice. The interior features mountains, valleys, and river systems in positions that roughly correspond to subglacial features we now know exist beneath Antarctic ice. The Ross Sea and Weddell Sea, the two major embayments of Antarctica, appear in approximately correct positions. The Antarctic Peninsula is shown, though its shape is somewhat distorted. The overall proportions of the continent, while not perfect, are recognizable. To achieve this level of correspondence by chance would require extraordinary luck, particularly given that Oronteus Phineas was working in 1531, nearly 3 centuries before Antarctica was officially discovered. Dr. Charles Hapgood commissioned a professional cartographic analysis of the Oronteus Phineas map by the United States Air Force's Cartographic Section. The analysis, completed in 1961, concluded that the map showed Antarctica with a level of detail suggesting the cartographer had access to source maps based on actual surveys of the continent. The Air Force analyst noted that the projection used in the map was sophisticated and that the internal geography corresponded to actual Antarctic features with accuracy that exceeded what random guessing would produce. This official analysis, though not widely publicized, provides technical validation that the Oronteus Phineas map genuinely shows Antarctic geography rather than speculative drawing of unknown lands. While most attention has focused on European maps showing Antarctica, some researchers have pointed to Chinese cartographic traditions as another possible repository of ancient geographic knowledge. Chinese maritime exploration reached impressive heights during the Ming Dynasty, particularly during the voyages of Admiral Zheng He in the early 15th century. Zheng He commanded massive fleets that visited Southeast Asia, India, the Arabian Peninsula, and the east coast of Africa between 1405 and 1433. Some controversial theories suggest that Chinese fleets might have reached the Americas and even Antarctica during this period. The most famous claim about Chinese Antarctic exploration comes from a controversial map dated to 1424 that allegedly shows both American continents and Antarctica. This map, if genuine, would predate European discovery of these regions and would suggest that Chinese navigators possessed geographic knowledge rivaling or exceeding that of Europeans. However, the map's provenance is disputed, and many scholars consider it a modern forgery, or at least a map that has been significantly altered in modern times. The controversy surrounding this map has made serious scholarly analysis difficult, as researchers fear their careers will be damaged by association with what might be a hoax. Setting aside the disputed 1424 map, there's no question that Chinese cartographic traditions were sophisticated and that Chinese navigators were capable of long-distance ocean voyages. Chinese sources mention lands far to the south, including references to icy regions and unusual lands where the sun barely rises above the horizon. Some of these descriptions could potentially refer to Antarctic or subantarctic regions. If Chinese fleets did venture into far southern waters, they might have created maps showing these regions, maps that could have eventually reached European cartographers through trade routes or diplomatic exchanges. This would provide another possible pathway for ancient Antarctic knowledge to enter the European cartographic tradition. The broader point is that ancient and medieval geographic knowledge wasn't confined to one cultural tradition. Information flowed between civilizations through trade, conquest, and scholarly exchange. An ancient map showing Antarctica created in one part of the world could potentially reach cartographers thousands of kilometers away through chains of copying and transmission. The map might be transformed in the process, with projections altered, features reinterpreted, and details lost or corrupted, but core geographic information could survive. The European map showing Antarctica might be incorporating knowledge that originated in Asian, African, or Middle Eastern cartographic traditions, all ultimately deriving from even earlier sources that remain mysterious. One often overlooked aspect of ancient Antarctic cartography is how several ancient and medieval maps show islands in the Southern Ocean that correspond to actual subantarctic islands that weren't officially discovered until the 18th and 19th centuries. The Piri Reis map shows islands in positions corresponding to South Georgia, the South Sandwich Islands, and possibly the Falkland Islands. These islands are positioned with reasonable accuracy relative to the South American coastline, suggesting that whoever created the source maps Piri Reis used had actually explored the southern Atlantic and documented the islands they encountered. South Georgia, discovered officially by Captain James Cook in 1775, appears on the Piri Reis map in roughly the correct position relative to South America. The island is drawn with some detail, showing a mountainous interior and an irregular coastline. This correspondence is significant because South Georgia is not a large island and would be easy to miss without systematic exploration of southern waters. Its presence on a 1513 map strongly suggests that pre-modern explorers did indeed venture into the far southern Atlantic, documenting what they found. If they explored far enough south to find South Georgia, located at 54 degrees south latitude, they certainly could have encountered Antarctic ice or even the Antarctic continent itself. The South Sandwich Islands, another sub-Antarctic archipelago, might also appear on ancient maps, though identification is less certain due to the small size of these islands and the distortions inherent in ancient projections. Nevertheless, some researchers have identified features on ancient maps that could correspond to this island group. The cumulative evidence from multiple subantarctic islands appearing on ancient maps reinforces the conclusion that pre-modern exploration of southern waters was far more extensive than official history acknowledges. Each island documented is another piece of evidence that ancient mariners possessed both the technology and the motivation to explore the world's most remote waters. Some researchers have proposed that Antarctica might have been accessible for mapping during a brief period when a coastal corridor was ice-free, even though the interior remained glaciated. This theory attempts to reconcile the ancient maps with geological evidence for long-term Antarctic glaciation by suggesting that not all of Antarctica was always completely covered. During warmer climate periods, coastal areas might have been seasonally ice-free, allowing ancient explorers to map shorelines even though they couldn't penetrate the interior. Evidence for this theory comes from geological studies showing that Antarctic ice coverage has fluctuated over time. During the Holocene climatic optimum, roughly 7,000 to 5,000 years ago, global temperatures were slightly warmer than today. Some Antarctic coastal areas might have experienced summer ice-free conditions during this period. If an advanced maritime culture existed during the Holocene climatic optimum, they could have explored and mapped Antarctic coastlines during the brief windows when those coasts were accessible. The maps they created would show the coastline as it appeared during ice-free periods, which might differ from both the current ice-covered appearance and the subglacial topography. This theory has the advantage of being more geologically plausible than theories requiring complete Antarctic deglaciation in recent history, but it still requires explaining how a sophisticated maritime culture capable of Antarctic exploration existed 7,000 years ago, a period when conventional history places humans in the Neolithic, living in simple agricultural villages. The theory also needs to account for how maps created 7,000 years ago were preserved through all subsequent millennia to eventually be copied by Renaissance cartographers. The chain of transmission would need to span dozens or hundreds of generations, surviving the rise and fall of multiple civilizations without the maps being lost or completely corrupted. In the 1950s, as part of the International Geophysical Year, researchers conducted extensive seismic surveys of Antarctica to determine the continent's subglacial topography. These surveys involved setting off explosions on the ice surface and measuring how seismic waves traveled through the ice and reflected off the bedrock below. The results revealed a complex landscape beneath the ice, including mountains, valleys, and a channel dividing Antarctica into two major landmasses. This information was completely unknown before the surveys, as it's impossible to determine what lies beneath kilometers of ice through surface observation alone. When researchers later compared the Piri Reis and Oronteus Phineus maps to the seismic survey results, they found striking correlations. Features shown on the ancient maps corresponded to subglacial features that had just been discovered. The division of Antarctica into two landmasses, so clearly depicted on the Boachi map from 1737, was confirmed by seismic surveys 2 centuries later. Mountain ranges shown in the interior of Antarctica on ancient maps aligned with subglacial ranges detected by seismic methods. These correlations couldn't have been predicted from surface observations because the ice completely obscures the underlying geography. Yet ancient maps showed this hidden geography with accuracy that seems impossible without either seismic surveying technology or observation of Antarctica in an ice-free state. The seismic survey comparison provides some of the strongest evidence that ancient maps contain genuine geographic information about Antarctica, rather than lucky guesses or speculative drawings. When multiple specific geographic features shown on ancient maps are later confirmed to actually exist in those positions by 20th century scientific surveys, coincidence becomes an inadequate explanation. The probability of guessing the correct positions of mountains, coastline features, and continental divisions by chance is astronomically small. The more reasonable conclusion is that ancient maps preserve information from actual surveys of Antarctic geography, however those surveys were conducted. One of the most challenging aspects of the ancient Antarctic maps is that they represent technological and knowledge capabilities that apparently disappeared for thousands of years before being reacquired. If ancient peoples could map Antarctica accurately, they possessed maritime technology, navigational knowledge, and surveying capabilities that weren't matched again until the 18th or 19th centuries. This represents a massive technological regression, with humanity apparently losing capabilities and having to slowly rediscover them over millennia. Such regression is difficult to explain within conventional models of technological progress. History does provide examples of technological regression. The fall of the Roman Empire led to loss of concrete-making technology, architectural techniques, and engineering knowledge that weren't recovered for centuries. The Bronze Age collapse around 1200 BC disrupted Mediterranean civilizations and led to loss of literacy and advanced metalworking in some regions. But these regressions were regional and relatively short-lived. the capabilities required for Antarctic exploration, if lost in ancient times, would have been lost globally and remained lost for thousands of years. This suggests a more catastrophic disruption than anything documented in historical times. The regression puzzle has led some researchers to propose cataclysmic scenarios that would explain both the loss of ancient capabilities and the lack of obvious archaeological evidence for the civilizations that possess those capabilities. A civilization concentrated in coastal regions would be particularly vulnerable to sea level rise at the end of the last ice age, when oceans rose over 100 meters and inundated vast areas of formerly habitable land. Such a civilization might have been largely destroyed, with survivors scattering and losing much of their technical knowledge. Later civilizations would have inherited fragments, including maps, without understanding their source or significance. The question of ancient Antarctic maps has created a sharp divide between mainstream academics and alternative researchers. Mainstream scholars generally dismiss the maps as showing either speculative geography or coincidental resemblance to Antarctica, while alternative researchers see them as strong evidence for revised history. This divide has become entrenched, with little productive dialogue between the two camps. Mainstream academics often refuse to seriously engage with the evidence, while alternative researchers sometimes overstate their case or embrace additional speculative theories that undermine their credibility. The cost of this divide is that serious investigation of genuine anomalies becomes difficult. A young scholar who wanted to research the ancient Antarctic maps in depth would face significant career risks. Publishing papers arguing for ancient exploration of Antarctica would likely damage their professional reputation and make it difficult to secure academic positions or research funding. This institutional pressure toward conformity means that even scholars who find the evidence intriguing are incentivized to either ignore it or offer only the most conservative possible interpretations that don't challenge established narratives. Meanwhile, alternative researchers working outside academia often lack access to resources, expertise, and peer review processes that could strengthen their work. Without institutional support, they can't conduct the kind of comprehensive technical analysis that might definitively settle questions about map accuracy and correlation with actual geography. They often rely on secondary sources and can't access original maps or conduct original archaeological research. This separation between alternative researchers who are interested in the questions and mainstream scholars who have the resources to investigate them properly means that the mysteries remain unresolved when they might be clarified through systematic study. If ancient maps do show accurate Antarctic geography, this has significant strategic and political implications beyond purely academic interest. Antarctica is governed by international treaty, with territorial claims frozen and the continent reserved for peaceful scientific research. But if evidence emerges that ancient civilizations explored or inhabited Antarctica, it could potentially affect territorial claims or resource rights. Nations might argue that historical precedent gives them rights to Antarctic regions, or conversely, that evidence of ancient occupation means no modern nation can claim territory on historical grounds. The resources at stake are substantial. Antarctica contains vast mineral deposits, though mining is currently prohibited by treaty. The Southern Ocean surrounding Antarctica contains fish stocks and other marine resources. Antarctica's ice sheets contain the majority of Earth's fresh water. As climate change makes some Antarctic resources more accessible, and as international competition for resources intensifies, the strategic value of Antarctica will likely increase. Any evidence affecting territorial claims or historical rights could therefore have significant geopolitical implications, which might explain some of the resistance to seriously investigating ancient Antarctic maps. Intelligence agencies might also be interested in ancient maps for different reasons. If the maps show geographic features or possible resource locations that haven't been discovered by modern surveys, this information could have intelligence value. If ancient maps suggest locations where ruins or artifacts might be found beneath the ice, agencies would want to investigate these locations before other nations do. The classification of portions of Hapgood's work on ancient maps by the U.S. Air Force might reflect such strategic calculations. Geographic knowledge, even if derived from ancient sources, can have modern intelligence applications that justify secrecy. One of the most contentious issues in evaluating ancient Antarctic maps is determining when the original surveys were conducted that produced the source maps later cartographers copied. The maps we possess, like Piri Reis and Orontes Phineas, date to the 16th century, but they claim to be based on much earlier sources. How much earlier? Dating the original surveys requires evaluating when Antarctica could have been mapped, which depends on uncertain climate history, and even more uncertain history of human technological capabilities. If we accept geological evidence that Antarctica has been substantially glaciated for millions of years, then the maps showing ice-free conditions must be either completely wrong or based on surveys from the unimaginably distant past, which is impossible. If we revise our understanding of Antarctic glaciation to allow for significant ice-free conditions during the Holocene period 7,000 to 5,000 years ago, we create space for human-era surveys, but must then explain how maps from that period were preserved. Through all subsequent millennia, if we propose even more recent ice-free conditions within the last few thousand years, we face even stronger geological objections, but reduce the time span over which maps must be preserved. The dating question is ultimately unanswerable with current evidence. We can't determine when the original Antarctic surveys were conducted because we lack direct evidence of those surveys. We have only the copied and recopied maps, generations removed from the originals, with no certain way to trace them back to their source. Different researchers propose dates ranging from a few thousand years ago to millions of years ago, depending on their interpretation of the geological and archaeological evidence. Until we find either the original maps or archaeological evidence of the civilization that created them, the dating remains speculative, which in turn makes it difficult to evaluate the plausibility of various explanatory scenarios. We return to where we started, to that moment in 1929 when Halil Adem opened a portfolio in the Topkapi Palace Library and discovered a map that shouldn't exist. Nearly a century has passed since that discovery, and we're no closer to consensus about what the map truly represents. The geographic correlations with actual Antarctic features remain, subject to the same debates and the same methodological disputes they've always been subject to. The maps sit in their archives, available for anyone to examine, yet they remain as controversial and as unexplained as they were when first recognized for their anomalous features. Perhaps this enduring mystery is itself significant. If the maps were obvious frauds, they would have been exposed and dismissed decades ago. If their correlation with Antarctic geography were clearly coincidental, skeptics would have definitively demonstrated this by now. The fact that the controversy persists, that reasonable people examining the same evidence reach different conclusions, suggests we're dealing with something genuinely puzzling rather than something easily explained. The maps occupy an uncomfortable middle ground, too anomalous to ignore, but too ambiguous to definitively interpret, challenging us to expand our historical models while not quite providing sufficient evidence to force such expansion. The mystery endures because the fundamental questions remain unanswered. Who conducted the original surveys that produced the source maps Renaissance cartographers copied? When were these surveys conducted? What level of technology and organization was required? Why did this capability apparently disappear for thousands of years? How were maps preserved through such enormous spans of time? Each question leads to others, branching into complex networks of historical, technological, and geological puzzles that resist simple answers. The ancient Antarctic maps are not a mystery that will be solved with a single discovery or insight. They're a window into questions about human history and capability that may take generations to fully explore and understand, if they can be fully understood at all.